Okay, this is Chapter 2, Section 2, an Introduction to Problem Solving. And our first objective is writing and simplifying algebraic expressions. So the first thing we want to do, we'll just do example 1, is write the following is an algebraic equation. So that's what we want to do first, is just write the equation. So here is the keyword, the sum, S. So you're going to note the sum is S. And sum means adding. So the sum of 3 consecutive integers, where x is the first of those integers. So our sum, we start out with S. S is going to be equal to x. That's going to be my first consecutive integer, but then I have to add 2 other items in the sum. So this is going to be my first. So this is going to have to be my second consecutive integer, and this is going to have to be my third. So this problem requires that you understand what an integer is. So remember, an integer is a number in the form of, they're basically plus or minus whole numbers and 0. So what does consecutive mean? Well, they're one after the other. So let's pretend like 7 is our first integer. Then the next one would be 8, and the next one would be 9. On the other hand, excuse me, on the other hand, if our first integer was 980, then the next would be 981, and the next would be 982. So how do I get, if I have 1 is my x, then 8 is x plus 1, and 9 is x plus 2. The same over here. If my first consecutive integer is 980, and I let that be x, then 981 is x plus 1, and 982 is x plus 2. So that literally tells us what we need to write here. So we're going to write in these spaces exactly what we just discovered. X plus 1 denotes the second integer, and x plus 2 denotes the third. So let's actually simplify all of this. So I'm going to go ahead and just give myself some more white space. So we discovered our equation was S is equal to x. That's my first integer. The integer right after it is x plus 1, and the integer after the second one is x plus 2. So to simplify, we just collect like terms. X plus x plus x, and then I have a 1 and a 2, plus 1 plus 2. So the answer is x plus x plus x. That's 3x plus 3. So this is my algebraic expression, where our variable x stands for the first of 3 consecutive integers. So that one's not difficult at all. That's 1A. We'll come back to this one in a bit, I'm pretty sure. So let's go ahead and do 1B. Just making sure I'm recording there. I've actually done entire lectures only to find out I never hit the record button. So the perimeter P of a triangle whose sides have lengths x, 5x, and 6x minus 3 Here, go ahead and draw a picture if you want. The triangle can be any triangle at all. Doesn't have to be perfect. So here are the sides of the triangle. And it says one of those, and it doesn't matter which one, is x. The other is 5x. And the other is 6x minus 3. And it doesn't matter if it's to scale or not. It makes no difference. So the perimeter of a geometric object is the distance is the sum of all of the sides. You can think about the perimeter as if you were an ant starting right here at this corner and you had to walk all the way around the triangle, restricted to just the edges. It's the total distance you would walk. So the perimeter, and we're going to denote that as P, is going to be the length of side 1 plus side 2 plus side 3, and that's equal to x plus 5x plus 6x minus 3. But again, we want to collect like terms and simplify. X plus 5x is 6x, and 6x plus 6x is 12x. So this is 12x minus 3. That's our perimeter. I have a feeling we're going to revisit this one too. I know we do some of them. And let's do 1C. Okay, the sum of 3 consecutive odd integers. So we're going to be using a very similar formula as we did in 1A, but in this case, x is the first odd integer. So the sum is going to be the first odd plus the second odd plus the third. That's supposed to be an I there. So let's give an example. If x is equal to 5, my next odd integer would be 7, and the one after that would be 9. On the other hand, if my first odd integer was 111, the next after that would be 113, and the next after that would be 115. So if this is equal to x, what do I have to add to x to get 113? Well, that's x plus 2. And what do I have to add to x to get 115? It's x plus 4. The same over here. If x is equal to 5, then 7 is equal to x plus 2, and 9 is equal to x plus 4. So that gives us exactly what we want. S is equal to x plus my second odd integer is x plus 2, and my third is x plus 4. So again, we want to collect like terms and simplify. We have 3 x's this time, and then we have 2 plus 4, which is 6. So our final expression is s is equal to 3x plus 6. Well, that was just terrible. Here, let's do it this way. Might as well use the line drawing tools they give me. So 1D. So you should try to do this one on your own. You've kind of got the hang of it. The only thing you might need here is a picture. And I'll draw a quick picture for you as a trapezoid. Not that way though. Let me get the drawing tools. Basically, well, I'm just going to draw a simple one. So there's a trapezoid, and we'll call the bottom is the base. So So there's the length. And again, we're talking about the perimeter, P. So here is base 1. We'll say this is base 2. And this we'll say is side 1. And we'll say this is side 2. So the perimeter is equal to base 1 plus base 2 plus side 1, which I'm just denoting as S1, plus, I said side 2, side 1 plus side 2. So this is kind of my really general guiding equation. But we're given that base 1 is x, base 2 is 2x, side 1 is x plus 2, and side 2 is 2x minus 3. So all we have to do now is just collect like terms and simplify. So here I have x plus 2x is 3x, plus another x is 4x, plus 2 more x's gives me 6x. Then let's find the constant terms. 2 minus 3 is minus 1. So the perimeter is equal to 6x minus 1. So for our next example, we're not going to do all of them. Yeah, I guess so. So we are revisiting all of this. So we want to solve equations A, B, C, and D with the following values. S is equal to 32. So let's go back and go up. And here is my equation. My equation is given by S is equal to 3x plus 3. Well, they say let x be equal to 32. Find the sum. So S, which stands for the sum, is equal to 3. Now I just plug in the value of x is equal to 32, where x is, so it's 3 times 32 plus 3. And, oh, sorry. I made this way too easy. It says solve the equations when s is equal to 32. We're not finding s. We're actually solving for s. So I thought that was way too easy. So we want to find s. There we go. We want to find not s, but rather find x when s is equal to 312. Okay, a little bit more challenging. Not really, though. So here's our equation that we're using. S, that's an S. It kind of looks like a 5, but it's an S. S is equal to 3x plus 3. So S is equal to 312, and that's equal to 3x plus 3. So again, I want to isolate the constant terms and the variable terms on one side. That means I'm going to bring the 3 to the other side. That results by subtracting 3 from both sides. So 312 minus 3 is 309, is equal to 3x. So now all I have to do is, I know how many 3x's are. I want to know how many 1x is. So I divide both sides by 3. And 309 divided by 3 is 103. And that gives us our value for x. Since you kind of see what's going on and these are pretty simple, let's go ahead and do maybe number D, where P is equal to 35. So here we go. So in this case, we are given by the problem itself that P is equal to 35. So our equation is given by p is equal to 6x minus 1. But in this case, we are given that p is equal to 35. Find x. So in other words, this is a formula. This is a formula that relates the perimeter of a specific type of a trapezoid with the lengths of its side. And we're given that p is equal to 35, find x. This is really, really common. So we're going to solve. I first let p equal to 35, and then I just write the equation down, and I'm solving for x. So I want the 1 on the other side, so I add 1 to both sides. So 36 is equal to 6x. So I know how many 6x's are. I want to know how many 1x is. So I divide both sides by 6. So the result is that our side length, x, is equal to 6. Okay, so now let's look at some general, those seemed almost too easy to be true. Let's look at some general steps for solving word problems. You got to read the problem first and understand the problem. What are the givens in the problem? Identify what the unknown quantity is, and find out how the givens, or the knowns in the problem, relate to the unknown quantity. We actually did that right here. We'll go through all of these and I'll go back. Translate the problem into an equation. Write down a general obvious relationship between quantities given in the equation. So here, we literally did that at the very, very top. All of these. The perimeter is equal to the side 1 plus side 2 plus side 3. That's a general equation. The perimeter of a triangle is always equal to the sum of its sides. And then I used specific information about each side length to fill in. Side 1 is x, side 2 is 5x, side 3 is 6x minus 3. So break down parts of 2a, that's the breakdown here that I just did, into quantities given in the equation. So p is my general equation, side 1, side 2, side 3. I broke down side 1, side 2, and side 3 into specifics, x, 5x, and 6x minus 3, and that was given to you in the particular problem. And then we just solved the equation, or at least we wrote, in the particular case, we wrote the general formula, and then we solved the equation for the unknown quantity. So notice here, we have the formula p is equal to 12x minus 3. So what that means is, if I'm given p, I can solve for x. I can solve for the side length. X is equal to the length of this side from the picture. And then I can find, once I know the value of x, I can find the value of the other sides. So let's actually, maybe I should do this one. Let's just pretend the perimeter is 15. The perimeter is 15. That's not what was given. Let's say the perimeter is 21. I just want to do this really fast because sometimes, cancel that. Sometimes I take it for granted that you would know what to do, and that usually gets me into trouble. So let's actually go back and do this one just as an example. We were given that the perimeter was equal to 21. So find the side length. So we solved 21 is equal to 12x minus 3. So I want to move the 3 over. So I do so by adding 3 to both sides. So 21 plus 3 is 24. And that's equal to 12x. So when I divide by x, when I divide by 12, I get 1x. 24 divided by 12 is 2, so x is equal to 2. But remember, x is just the side length, and suppose that the problem wants to know the lengths of all the sides. So x is equal to this length, so the length of this side is 2. 5x is the length of this side, so the length of this side is 10, and 6x minus 3 is the length of the final side, so 6 times 2 is 12 minus 3, and that's 9. So that's the completion of that problem. So many times, once you find x, depending on the problem, you may still have other things to do, because x just got me the length of one side, so I need to find, in this particular case, the length of the others. Solve the equation, and then conceptually check your solution. This is really important. I get some of the most insane answers. Does it make sense? I literally once had a student solve a problem. Basically, it went something like, and this is not as uncommon as you might think, you're selling a chair at a yard sale, and it cost $15.20. Someone gives you $20.20. How much change do you owe them back? And it's $5. I've literally had students write, you owe them $25.20, or something insane. Literally, you owe them more money than they gave you. And of course, conceptually, they would never make that mistake if they would have stopped and thought about it. But you know, in the pressure and timed pressure of a test, it can make a difference, a lot of difference, if you can check. And when you're taking a test, if you are worried about that and you do a conceptual check and you realize it's wrong, write a note down. I realize this is wrong, I don't know how to fix it, and I'm running out of time. That clues me in that you've done something extra. And it helps me justify giving you partial credit. So suppose a computer store just announced an 8% decrease in the price of a computer you wish to buy. If the computer sells for $2,162 after the discount, find the price of the computer. So what we need to do here is we've got it kind of these types of questions kind of assume some familiarity with formulas, and indeed for the prerequisites of this course you should have that familiarity. So let's think about the original price. So the original computer price, what is it? It's equal to something. It's equal to the price after the discount plus the discount, right? Let's give an example for that. Suppose something costs $25, that's how much it cost, and it's discounted by 3, so the discount is 3, and you pay, therefore, $22. So the price after discount is the price I'm saying you pay. If you add the price after discount plus the discount, you get the original price. So we're going to use this general formula. This is the guiding formula. This is the formula I talk about in step 2A. So in this case, let's identify the unknown value. So find the price of the computer. And by the price, I mean the original price of the computer. So that's going to be my unknown. So my x is going to be the original price. So the computer sells for $2,116 after the discount. And then I have to figure out the discount value. I've not used all of my information, right? The discount is an 8% decrease. So the discount is 8% off the original price. But the original price is X. So 8% off the original price is 8% is over 100 times X. So we have a formula. X is equal to $262 plus 8 over 100. So 8% is 8 per 100 times the discount, which is the original price. So here I have my equation. So what do? This has a fraction. So if you want to make them all have fractions, you can put the $2,162 over 1 if you want, but we want to multiply by the common denominator, and that's 100. So we're going to multiply both sides by 100. And the important thing you do here is you literally multiply all of both sides by 100. On this side it's really easy. On this side I'm going to do it. So this gives me 100x is equal to 2,162 times 100. I just add 2 zeros to that. Don't make it difficult. And then 8 divided by 100 times 100 is equal to 8, and that's times x. So now what do? Well, what I'm going to do is give myself a little bit more room to work. We want to collect like terms. That means the variable term here is going to go to the other side, and I'm going to have 100x minus 8x is equal to 216,200. So that's going to give me 92x is equal to 216,200. And what do I have to do now to find x? I have to divide both sides by 92. And that gives me a value of x is equal to $2,350. And what was x? X is our original price. Does that make sense? Yeah, the original price is going to be greater than the price you pay, and the price you pay is $2,162. So an original price of $2,350 makes sense. Okay. So in this case, let's just think about this 1 second before I move on to the next problem. This was key right here. First, just realizing an equation in words that the original computer price, or the original price, is equal to the price after discount plus the discount. Now, I don't expect you to memorize that. You should be able to think that through, and one of the ways that we can think that through is we used a little example, didn't we? Did I erase it? I erased that example. But I gave an example of if you pay if something costs $25 and it's discounted by 3, then you pay 22. So the original price is the discount plus what you pay. And that helps you get there. Okay, example 3. Let's go to one more. just trying to see, is this our last one? No. So find the total amount of money in cents, not in dollars, but in cents, in Y quarters, 7Y dimes, and 2Y minus 1 nickels in terms of the variable Y. And then calculate how much money you have if Y is equal to 10. So this isn't so bad, is it? So our total money, our general equation is going to be really simple. So my total money, well, my total is equal to how much money I have in quarters plus dimes plus nickels. But that's not quite it, right? Because my total is going to be in cents. And how many cents is equal to a quarter? It's 25 times my quarter value. And what is the value of my quarter? Is Y. So it's 25 times Y plus 10 times how many dimes I have, which is given as 7Y, and plus 5 times how many nickels I have, 2Y minus 1. So the total is 25Y. So the total T is equal to 25Y plus 10 times 7Y is 70Y. And here I have to use distribution. 5 times 2Y is 10Y. And 5 times minus 1 is minus 5. So let's go ahead and combine like terms. 70 plus 10 is 80. 80 plus 25 is 105Y minus 5. And remember, Y is given to you is the number of quarters. So now we're going to find out how much money you have if Y is equal to 10. So suppose you have 10 quarters. Then how much I have in cents is equal to 105 times 10 minus 5. Again, don't grab your calculator. 105 by times 10, all you have to do is add a 0 to it. Minus 5. And that's equal to 1045. And that's in cents. So if you want to know how much you have in dollars, what would you do? You would divide that by 100, so you would have $10.45. So let's look at example 4. So if 90% of the state of Nevada is federally owned, and the total number of acres of land contained in Nevada is 70 million, find the total number of acres not federally owned. So our unknown is given to us immediately, and we'll let our unknown be x. X is equal to number of acres not federally owned. But we have the total acreage. The total acres is split. So you can draw a little picture if you need. Just pretend that's Nevada. And we have two parts. The part that is Fed-owned and the part that is not Fed-owned over here. So the total acres is going to be Fed-owned plus not Fed-owned. But the total number of acres not Fed-owned is my X value. So the total is equal to Fed owned plus my X. So I'm going to solve for X now. So X is going to be equal to the total minus the amount that is federally owned. That's misspelled, that's okay. And that's equal to X. So let's get some more room up here. So the total number of acres minus that Fed owned is equal to X. So the total number of acres of land contained in Nevada is 70 million. So don't write this as 70 million. Don't start writing 70 million. Just write 70 and realize that your units is in millions. So 70 millions. Minus, how much is Fed owned? 90% of that. 70 million is Fed owned. So when I get my value X here, X will be in millions of acres. You don't want to do that. So 70 minus 90% of 70, well, that's not so bad. That's 70 minus, we can take off one of those. You can do this however you want. I mean, if you want to multiply 70 times 0.9, that's also fine. But that's going to turn out to be 70 minus 63, and that's going to be my X. So let me explain to you what I was doing over here. I have 90 times 70 over 100. So 9 times 7 is 63. So 90 times 70 is, I add 2 zeros. And then I'm dividing it by 100. So the answer is, that's that old trick, is equal to 63. So 70 minus 63 is 7, is equal to X. X is in millions of acres, so the total amount of land not federally owned is 7 million acres. Do we have one more example? Yeah. In a recent survey, 15% of online shoppers in the USA reported that they prefer to do business only with large, well-known stores like Amazon or Walmart. And a group of total 1,500 online shoppers, how many would be willing to do business with any size retailer? So we have a group of shoppers here. This is translating concepts. So we have two groups of shoppers. We will have group 1, shoppers. We're going to divide our shoppers into two groups. Group 1 only shop at large retailers. That's it. They don't shop anyplace else. And our group 2 is, we'll shop anywhere. And someone who will shop anywhere is not in the group that will only shop at large retailers. And if you're a group that only shops at large retailers, then you cannot be in the group that shops anywhere. So these two groups are mutually exclusive, and together, mutually exclusive means you're either in one element or the other, one group or the other, and both groups make up the total shopper. So total shoppers is made up of those in group 1 plus those in group 2. So it turns out in a group of 1,500 online shoppers, how many would be willing to do business in any size retailer? So we want to know the size of group 2. So let X be the size of group 2. And we know that the total number is equal to, well, let's go ahead and solve for X. So the total minus the number in group 1 is equal to X, because I just replaced group 2 with X, and I solved for X by moving the number of group 1 to the other side of the equation. So how many total online shoppers do we have? We have 1,500. And of those 1,500, 15% of them belong to group 1. So how many are in group 2? All I have to do is solve this equation. So it's going to be 15,000. And again, using my trick, if you know the trick, when I'm dividing by, since we are using base 10, since I have 2 zeros up here, I have 2 zeros out here. So this is minus 15 times 15, which is 225. And that gives me my value of X, which is 1,275 members of group 2, because X was the size of group 2. Okay. So now we have, oh, that's it. So that is it for this particular section.